Hi, hello everyone. I'm Dr. Prasad Pudilam. Welcome back to my YouTube channel, My Intuition. Continuing my class series on biology for engineers. Last module, module 5, second topic, third topic actually. Not even third topic, fourth or fifth topic actually. So, module 5, I covered the bioprinting techniques and materials, covered the 3D printing of ear, bone, skin, now, and even 3D printed foods. In this particular class video, I'm trying to explain about the electrical tongue and electrical nose in food science. Okay, so these video classes are available on my YouTube channel. All that classes from module 1 to module 5 classes available at my YouTube channel, My Intuition 4865. And if you want to purchase the study material, each module I'm charging 10 rupee each. Okay, so you need to call, you can contact me to purchase the notes 797 I'm not giving for free now onwards. Okay, so you can purchase it by paying 10 rupee each for each module, or as such 40 rupees I am giving all the complete 5 module notes. So module wise, if it is purchase want to purchase, that is 10 rupee each. Okay, so moving to the third topic of this chapter, that is okay, all these are covered already in the previous class. I explained in detail even up to the food, the printed 3D printed food. So this particular class video covers electrical tongue in food science as well as electrical nose in food science. Okay, so before that we should have already we know, and we have to review and revisit our information regarding the human tongue. Okay, so this represents the map of a human tongue with taste bud sections, sweet in the front, salty on the front side, sour taste on the sides of the middle or back side, bitter comes at the back. Okay, so human tongue plays a crucial role in the sense of taste, allowing us to perceive and distinguish various tastes. uh, some of the overview of how this taste buds or this sensing is working, that is given here. Taste buds, the surface of tongue, it is covered with very tiny structures called the taste buds. The taste buds contain specialized cells called taste receptor cells, which are responsible for detecting different taste qualities. Then taste receptor cells, there are five primary taste quality recognition by taste receptor, like sweet, salty, sour, bitter, and even savory. Called as umami. But each taste receptor cell, it is sensitive to a specific taste compound associated with these qualities. Then it goes to the taste pores. The taste receptor cells have small openings called taste pores, which are in direct contact with the oral cavity. Through these pores, taste compound dissolved in saliva come into contact with the taste receptor cells, and it binds to the means binding of taste compound. When taste compound enters the taste pores and come into contact with the taste receptor, they bind to a specific receptor on the surface of the cell. Each taste receptor cell is specialized to detect a particular taste quality. Then it goes as neural signals. These signals are transmitted to the brain via uh, cranial nerves, especially the facial nerve, glossopharyngeal nerve, vagus nerve, etc. And the processing happens in the brain will do the processing, and uh, a taste perception happens. The brain's interpretation of the signal from taste receptor cell allows to perceive and differentiate various tastes. The combination and intensity of signals from different taste qualities give rise to the complex flavor we experience when we eat or drink. But only the thing which I want to specify, I want to clarify, because this type of doubts arise to me. We define that whatever comes that sweet taste, okay, we feel very happy. We only given that name sweet, then we can keep it as a salt also. Okay, how it is very salty, means in place of a sweet. So brain, it will not say that it is sweet or it is salty or sour or bitter. It will differentiate the taste, different taste. We only defined, the human beings only defined, this is sweet, the other one is salty, sour, bitter. Names we only kept. Different languages, it has different uh, names. Okay, so brain will not tell that it is sweet or sour. Okay, so it will differentiate that difference in the taste, it will differentiate. Now how this electrical tongue can work? If we are in place of our tongue, or if you want to use want to taste without simply tasting each and nowadays, even now, many of the food industries, we have specialized persons. His duty is to take the food, the taste, and wash the mouth. Okay, uh, he's a specialized food taster. Okay, and it is highly paid salary job also. Okay, so in order to replace that, or to give a precise this one, if we cannot depend on a person, sometimes if the company is not giving proper salary, he may give the wrong answer also. Okay, so all those confusion, okay, just for a fun I said, nobody will do like that. If they do, they will be in trouble. Okay, it comes as the under the ethical terms. He has to sign some ethical terms and conditions. Okay, so now the electrical tongue. The electrical tongue, it is a device which is used in food science to analyze the taste and flavor of food and beverages. Mainly the taste and flavor that comes under electrical nose. Okay, it works by measuring the electrical conductivity, impedance, capacity of food or beverage sample, which are related to the concentration of ions in the sample and texture of the sample. That means that whatever food material that we you want to use, it will have its own conductivity property. It will have its own impedance property. It will have its own ions, because every food, it is carbohydrate, or it is something which is organic, or okay, some chemistry is there. Some ionic state, if it is liquid state, ionic state is there. If it is solid state, then also we can separate. Okay, so there are molecules, different molecules. So different molecules have different properties, so that can be identified. The food material which gives sweet, sugar materials, their chemical properties different to that of the one which is salt. So this can be identified using the chemical method, or using some measuring methods. Okay, so now the technology behind electrical tongue. Okay, so we are combining many of such sensors, or many of such testing possibilities combined, and made an array, sensor array, which is used. Okay, now which are the sensor arrays which are used in electronic tongue? It include potentiometric ion selective electrodes. Okay, we have ion selective electrode that you might have studied in first year of engineering, first semester, second semester in your chemistry cycle. uh, they have ion selective electrodes are there. You mainly you might have studied about glass electrode. Same type. Ion selective electrodes can be similar. Ion selective electrodes can be used. Voltammetric sensor, which will measure the change in the voltage of the corresponding to that molecule of the food. Impedance sensors can also be used to measure the impedance. Optical sensors in which a fluorescent light it is mainly used. The behavior of the molecule, the food molecule, food component molecules towards the fluorescence, it can be measured. Conductometric sensors, we can measure the conductance of the food. Okay. Okay, so for example, a conductometric sensor may measure changes in conductivity caused by binding of umami compounds to its surface. Then we have mass sensitive sensors, which also can be used. So a combination of all these together, if they work, then it will give some of the best sensing mechanism, different taste, or different the molecules which gives the different taste, which we feel in our tongue. The same thing can be measured using, or can be analyzed measured using some of the sensor arrays. Now, in a sensor arrays, some materials also has to be used. A sensor array means it is something equipment which consists of a material used. So the material which are used, it vary from polymers to metal oxides to carbon nanotube, dendrimers, microfluidic device, etc. So polymers like polyvinyl alcohol (PVA), PE or polyethylene oxide can be used. Metal oxides like tin oxide, zinc oxide are commonly used. Then nanotubes, carbon nanotubes, which are made up of carbon, they also are used such applications. Then dendrimers, they are branched nanostructures which can also be used. Microfluidic devices, microfluidic means micro-sized devices which will measure the or which will manipulate a very small volume of fluid. Very small volume is micro level, that much volume of fluid it can be used. So these are the materials which are used. Now some of the comparison between the functioning of human tongue and electronic tongue. I found it very interesting, that's why I made this list. Excuse me. Okay, since it is over video conferencing, no issue. There is some allergic action. Okay, now different aspects, how it different between human tongue and electronic tongue, which is mentioned here. And the sensing mechanism, if you take human tongue, it has got taste buds on the tongue which will detect the taste compound. Electronic sensors by using the chemical properties of the patterns in which the food material will behave. Taste perception. Human perceive basic taste qualities like sweet, salty, sour, bitter, umami, etc. Electronic tongue can be programmed to detect various taste quality, but it may not perceive taste in the same way humans do. Therefore, based on the practical application, means based on how we feel, if a food feels sweet, so we feed that same thing to the electronic tongue, that if such materials are detected, you have to tell it as a sweet. Okay, so we are forcing the electronic tongue, or we are directing, instructing the electronic tongue to give the result. Okay, so first feed we only giving. Then later onwards, if it founds sweet, it will say sweet. If it founds salt, it will say salty. Okay, the sensitivity. Human taste buds are sensitive to low concentrations of taste compounds. Electronic sensor can have high sensitivity to detect a very minute difference in chemical properties. Therefore, even compared to our sensing, the electronic sensor can have better sensing. Or we have to be very much hungry, too much hungry, means not eaten for 2 3 days. Then we can feel all the senses. Okay, very minute quantity food also will sense. Okay. Okay, subjectivity. Next point. Perception of a taste is subjective and can vary among individuals. Electronic tongue provides objective and standardized measurements. Limitations. Human taste perception can be influenced by factors like smell, temperature, texture, and personal preferences, whereas electronic tongue may not fully capture the complexity and nuances of a human taste perception. Okay, so it varies from person to person. Even if you are eating salt, if very good sweet smell comes, then we may feel that the food is salty or sweet. Confusion will come to a person. Okay, so that atmosphere also creates the temperature, the texture of the food, and every person has their own preferences also, as well as the atmosphere, the fragrance in the atmosphere, which also gives a taste to our food. That's why many of the hotels, they keep their atmosphere in such a way that the lightings, the temperature controlled, the food texture, and even the fragrance they put will make us to eat, even if the food taste is not so good, but we'll feel like it is very good taste. Okay, so these are the perceptions we have. Then throughput, human testing is a relatively slow process. Electronic tongue can analyze multiple samples simultaneously, providing fast and high throughput analysis. Okay, throughput. Okay, we put taste when we do the tasting. Somebody will prepare food and tell us to taste this. We will take a little bit. We put inside, then then we tell the taste. Maybe that is this very slow, relatively slow process. Not like when touching it, we won't respond. Okay, it will take time for us to think and analyze and tell. Okay, just again, a funny thought came to my mind. So, maintenance and calibration. No maintenance or calibration required for the human tongue. Electronic tongue requires calibration to ensure accuracy and consistency of the sensor response. Maintenance is required. We have to wash our mouth after eating. We have to clean our tongue also whenever possible. Before food or after food, it's better to clean our mouth or tongue, though it is mentioned that no maintenance required. Maintenance means no need of repair work, no need of calibration. We don't want to screw tight and make it proper each and every time. So that such a calibration not required. We only have to keep it clean. Or our mouth only will clean it with the saliva. It will wash all that one. It will do that work, but still we believe that we have to put water and clean. Okay, so that is the way we got trained from our ancestors. Okay, so something will be there, so we have to do that. Application: human testing is commonly used in food and beverage industries for sensory evaluation and quality control. That's what I said. This is a job opportunity. If you are a very good taste finder, you can distinguish all the different tastes, so you can apply for this type of a job. No qualification as such required for some of the jobs. Highly paid salary. Okay, so electronic tongue, it is used in various applications including food and beverage analysis, quality control, and flavor profiling. Now, advantages of electrical tongue technology. I'll put it next slide. They are non-invasive, high throughput, objective analysis, and cost effectiveness. Okay, so everything almost I explained, so I'm not again giving the explanation. Limitations: like it has got limited sensory experience, incomplete understanding, interfering factors like temperature, humidity, the storage condition, which will vary. Calibration issues: it has to be the electronic tongue has to be calibrated each and every time with the non food material, or with the non taste we need to calibrate. Okay, now it is going to tongue to nose. Tongue and nose, they are almost connected actually. Okay, so humans, we use the fragrance. The fragrance, even it will is connected to our tongue also. So with the fragrance, we will feel the taste. Okay, so this is the just representation of the olfactory system. Our nose system we call it as the olfactory system. We have nasal cavity, that is the present the whatever space it is there, that is the nasal cavity. Olfactory nerves are there inside. Then there is an olfactory bulb, then olfactory tract. Okay, these are all the one which is used and giving sense, taking it to the brain. Okay, the human nose, it is capable of sensing different aromas through the process known as the olfaction. The different aromas, how it sense it is mentioned here. Olfactory epithelium it will take, then olfactory receptor cells, odor and molecules, odor and detection, binding and signal transduction, olfactory bulb, then neural interpretation. Okay, so I'm not going in detail of this explanation. It is given here so that we can understand. That is in little bit depth biology it is. So things are kept here so that we should know what is the functioning of normal nose. Then we can go to the engineering application. Okay, so we need now electronic nose. Okay, not only tongue, we need electronic nose also. So in future, when artificial intelligence comes to its maximum peak, then robots will come. Robotic artificial intelligence, then it needs the electronic tongue, electronic nose, everything needed. Okay, now electrical nose or electronic nose, it is now we are using in food science, just food analysis. to check the aroma flavors, to identify the flavors. Actually, aroma flavors, they are nothing but volatile organic compounds. We call it as volatile organic compounds. Okay, so that smell, that particles which are coming, which are not visible to our eye, but they are coming, we call it as volatile organic compound, which our nose will capture, and it tell the different aromas, different smell, we call it as. Okay, the sensor in the electrical nose work by measuring the changes in the electrical resistance or capacitance that occur when a sensor are exposed to volatile organic compound. Again, sensor array is there. The sensor array mainly consists of tin dioxide, not down, okay, metal oxide sensors such as tin dioxide, or tin dioxide is not needed, tin oxide is okay. Tin oxide, okay, we don't do hold as tin dioxide, tin oxide, zinc oxide, stannous, stannic, like that, okay. That is tin oxide. And the conducting polymer sensors are used. Quartz crystal microbalance sensors are used. Surface acoustic wave sensors are used. Optical sensors are also used, like surface plasmon resonance. Gas chromatography sensors are also used. These are the sensor arrays, different sensing techniques, using either metal oxide or conducting polymers, like that. Different sensing materials are used to prepare the uh, sensing array. Combined array means it combines everything. It's a arrangement, proper arrangement of all these. The materials used, like polyvinyl alcohol, carbon nanotubes, tin oxide, zinc oxide, dendrimers, microfluidics, etc. Again, comparison is given. Sensing mechanism: olfactory receptor cells in the nasal cavity detect the water molecule. Electronic sensor detects the analyzed chemical of the water molecule. Odor perception: human can perceive a wide range of distinct odors. Electronic nose can identify and differentiate various odors, but may not perceive them in the same way as humans do. Then regarding sensitivity, subjectivity, limitations, throughputs, maintenance and calibration, same explanation as given to electronic tongue, same, almost same for electronic nose also. Here also it explained that difference between the electronic nose as well as biological olfactory system. Okay, so when odor and molecule comes, we will our olfactory nerves will catch that too, and it will be neurons. So this is the um, uh, communication between nerves. It will go to the brain. Brain will do the analysis and it will tell that oh, this is that particular different smell, and we give a name for that. Humans will give a name for that particular odor, and that becomes the name. Okay. So order perception, order signal generation, order signal processing, and order identification takes place, and with the smell itself, we will identify a particular food material is getting ready. Electronic nose, it uses sensor array, then sensor response, then it do the calculation there, feature extraction, then pattern recognition, then it will tell possibly this particular food is getting ready. Okay. Now advantages: rapid analysis, non-invasive, objective analysis, repeatability is there, cost effectiveness are the advantages. Limitations like limited sensory experience, calibration challenges, limited range of volatile organic compounds, technical challenges are there, high cost is there. Okay, so not much complications, simple sentences it is given here. So these are the limitation. Now coming is origami, biocomputing. Okay, all this very interesting topic. One more class I needed to complete this, so that this notebook also, module 5 notebook also will be made available for purchase. Okay, so thank you very much for watching my YouTube channel. uh, my name is Dr. Prasad Putila. and my YouTube channel, My Intuition 4865. Please do subscribe. Please do view a little bit at least, or what topic which is your interest. Please share this information to others and inform others that my notes are not freely available. I am not giving free. Those who purchase it, they can give it to others free. But I took much effort on preparing this study materials, so I am not giving free. You can't purchase it from that because I have expenditure, my own expenditure of preparing this study material also. So thank you very much once again. Have a nice day.